Hi everyone, welcome back to Invent Academy. Today we're going to be going over real world applications in Excel and overall it's based on money. And I'm Sarah, I'm a sophomore in mechanical engineering and my favorite food is mac and cheese. So let's dive into it. So today we're going to be doing an overview of functions, specifically present worth and future worth of money. And this deals with investments and interest rates and time period. And then we're going to go over the usage in STEM courses, specifically in engineering economics is what we have experience in. And then the materials needed are a Google account with access to Google Sheets and a computer, which is good. So to start off, we're going to the link on this page to follow along. So we're going to go and then you can go file, make a copy so you can have access to this later on and follow along with the examples, and you're gonna press OK. And we're gonna go back to the slides really quick. So the present value or present worth of money is a concept that states an amount of money today is worth more than the same amount in the future. So if you have $100 today, it's not going to be worth the same amount in say 5 years. And this is because inflation, economic principles, money just depreciates over time because our prices of different products fluctuates all the time. So if you want to find the present value of money, you need to know the interest rate. Usually it says compounded monthly or annually, which means that interest rate is applied either monthly, like to your money, or it's applied annually. So it could be once a year, it could be twice a year, it could be 4 times a year, it could be anything like that. And then you're going to want the targeted time period. So if you have money today, when do you want to take that money out? Or how much money do you want by a certain date? So if you have, say you want to get money out 5 years and it's compounded monthly. So since it's compounded monthly, you'd apply the interest rate 12 times over a year. So that would be 5 times 12. So that'd be 60 is your targeted time period, because that's the number of times it's compounded. And then the amount you want to withdraw is also another something you need to know to find that present value. So if you put in 100 today, you want 500 out later, you're going to input that. And this is the formula at the bottom. It says to find the present value, you're going to do equals present value, which is PV. Open the parentheses, you're going to put your interest rate, usually with a percent, or you're going to just put a cell. And then you're going to do comma n per, which is the number of times or the period length. It depends on how much, like when you're compounded. And then you can either do payment or future value. Payment is if you're withdrawing money every so often throughout like however long it is. And then future value is if you are just given what you want to withdraw. So you could do either of those. So we'll go back to the Excel and go to the present value tab. And this gives you an overview of the function. So the parameters, as we said, are rate, number of periods, payment, or future value. So here's an example. You're given the rate is 4% compound annually. So that just means it's done once over the number of years. The periods is 10 years. So that's just going to be 10 because you're compounding annually. So it's once every year. We're not given a payment, so that doesn't matter. And you want to get out 121,000 at the end of your 10 years. So to do present value, do equals PV, open parentheses, and then you do 4%. So I'm just going to click the cells this time. And then the number of periods, which is 10, so that one. And then the next input would be payment, but since we don't have that, we just do a comma and then we just leave it blank. So you just leave a blank space and then just add another comma. And then you want your future value of 121. And then you close the parentheses and press enter. And that'll give you 81,743.26. And the reason it's red and negative, it just means this number should technically be negative because we want to take it out at the end. So you need to switch this, but there's something different with that. Anyway, there's some examples here at the bottom that you can do on your own. You can pause the video really quick and try those yourself, and we'll go over them shortly. Okay. So to find using a 7% annual compound interest rate, what investment today is needed to withdraw for $1,000 annually for 10 years? So this one, you're not given you're given a number you want to annually withdraw, so that's the payment. You're not given your final value. So you could do PV and then your interest rate, which is 7%. The number of years, which is 10 years. Since it's compounded annually, it's only once per year, so it's only 10 periods. And then you want to withdraw 4,000, so negative 4,000, because you're taking it out, so it'd be negative. The answer is 28,094. So what deposit today is required to be worth 157,028 years if the deposit earns 3% annual compound interest? So this time we're given the future value, the number of years, the interest rate is 3%, and it's compounded annually again. So just 28 years is the number of periods. So equals PV, 3%, 28, comma, and then they're not given the annual withdrawal, so you do another comma, and then you do 157. Answer is 68,621. And then this last question, you wish to accumulate 114 in savings account in 10 years. So that's your final value and your period. If you want to make a single deposit today and the interest rate is 6% compounded annually on deposits of this side, how much did you deposit? So equals PV, 6%, 10 years because it's compounded annually, so it's once per year for 10 years. You're not given an annual withdrawal amount, so then you want to get 114,000. And that is, you need to deposit 63,657 today to get that amount in 10 years. Okay, going back to the slides, we're going to talk about future value now of money. So the future value of money is what money is expected to be worth in the future. So like I said before, the present value is not the same as the future. Usually it's a little bit more, or it could be less. It's actually probably worth less more in the future because prices change. So the parameters for this one are very similar to the last one. They're basically the same. It's just you switch out future value for present value, like you can see at the bottom. But we'll go over it again. So the interest rate, you want to know it's compounded monthly, compounded annually. It's basically how many times you're applying it to your sum of money per year. The targeted time period, like we said, if it's 1 year and it's compounded monthly, that'd be 12 periods because you're applying it to your money every month. But if it was, say, annually for 2 years, it'd only be 2 interest periods. And then you want to know the amount you want to withdraw annually or the present worth. You can input either of those. So we'll go back to the future worth tab on the Excel sheet. And you're given some examples again. So we'll do one at the top. It gives you the overview of the parameters and what it will do. So future value, you're given 4% compound annually for 10 years with deposits and a present value this time. So do future value, 4% for 10 years with annual deposits of 100 and then initial investment. enter 149, 225, sorry. So if you want to try these two by yourself really quick, and then I'll go over them in a minute. You can pause the video and try them, and we'll be back in a few seconds. Okay, how much will a 34,500 investment today be worth in 10 years if it earns 9.5 annual compound interest? So you're given the rate, the period, and the initial investment, so we don't have to worry about the annual deposit payment. So equals future value. The rate is 9.5%. The period is 10, and then comma, since we don't have any annual deposits, it'd be 34,500. 85,498. And then the last question is, you deposit 2,500 in the fund each year for 10 years. So that's your annual payment deposit. The interest rate is 5% compounded annually. How much money is available to withdraw immediately after your last deposit? So that's how much you want to find how much you can take out at the end of your period. So future value, interest rate is 5% for 10 years, and you deposit 2,500 each year, and you're not given the present value. So that'd be, you're available to withdraw 31,444 after the 10 years. Okay, going back to the end of the slide, we'll finish off with some usage in STEM courses. So these topics were introduced in industrial and operations engineering class that I took. It's about engineering economics. It has a lot to do with money and interest rates and stuff like that. And you learn about basic principles of engineering economics and how to use them to make informed economic decisions. So if you're given this money and it's worth that at the end of that time period, do you do it, or do you withdraw it or not? And then this class is probably the most heavily focused class on Excel that I've used to solve problems. It probably uses Excel and Google spreadsheets the most in a major that I've heard of. And even though it's probably the most you'll ever use it in this major, it's still valuable to know the basics and learn ways that money could be used to solve problems, or even use Excel basics to solve problems. And it's a valuable skill to know, especially if you're just making random spreadsheets and just want to solve problems very fast. So that was our video today. Thank you for joining. Have a nice day, and thank you for listening to all of our Excel videos.